Scientists are freaking out. Harvard's Avi dropped bombshell findings about the mysterious space object 3 Atlas racing through our solar system. What NASA first called a comet is showing impossible behavior that has Loeb worried. It's glowing with power equal to 10 nuclear plants and following a suspiciously perfect path past Earth. Sync to 0, where we will figure out it must be a comet or will rise all the way to 10, in which case the stock market may crash. Is this really just space rock, or are we being watched? The truth is scarier than anyone imagined. Unusual brightness pattern. When NASA's Hubble Space Telescope captured the first clear images of 3I Atlas, scientists immediately noticed something strange that doesn't match what we typically see with comets or asteroids. The way light spreads around this object breaks all the normal rules of space physics. Most space objects like comets have a glow that fades gradually as you look further from their center. Like walking down a gentle slope at the beach. The light gets dimmer bit by bit in a smooth, predictable pattern that scientists can easily measure and understand. But 3I Atlas is completely different. The brightness around it doesn't fade gently at all. Instead, it drops off suddenly and sharply, like stepping off a cliff edge. One moment, there's bright light, and the next moment it's gone. This sharp cut pattern is exactly what you'd expect to see if the light was coming from inside the object itself, like a powerful flashlight or energy source, rather than just sunlight reflecting off its surface. It's as if something inside 3I Atlas is generating its own light, which then illuminates the space around it. The Hubble images show this weird glow is concentrated at the front of the object facing the sun rather than trailing behind it like a comet's tail would. This positioning doesn't match what we know about how comets work, where material streams away from the sun. Scientists try to explain this as dust evaporating from the object's surface. But the numbers just don't add up. The way the light appears and disappears so sharply suggests something much more unusual is happening. Something that can't be explained by normal space physics. This pattern was the first major red flag that caught Loeb's attention and made him wonder if we might be looking at something truly unprecedented in our solar system. Not just another weird comet, but something potentially artificial. Nuclear power output. The most shocking discovery about 3 Atlas is the massive amount of energy it appears to be generating. After analyzing all the data from multiple telescopes, Loeb calculated that this object is putting out energy equal to about 10 nuclear power plants running at full capacity, roughly 10 GW of continuous power. To put that in perspective, that's enough energy to power a major city. The Hiroshima bomb released about 15 kilotons of energy, and 3I Atlas is producing that much power every few seconds continuously. This is what really sets off alarm bells. Natural objects simply don't generate this kind of energy on their own. Even the brightest comets we've ever seen don't come close to this level of output. Comets glow because they reflect sunlight off their surface and dust tails. They don't create their own light. What's even stranger is that this energy output has remained steady. As the object travels, it's not fading or changing like you'd expect if it was simply ice melting or dust burning off. Something is consistently generating massive amounts of energy inside or around this object. Loeb explored every possible natural explanation for this energy signature. Could it be a tiny black hole? The math shows that would only generate about 20 nanowatt millions of times too weak. Could it be radioactive material from a supernova? The universe doesn't have enough loose radioactive matter to explain it. After ruling out every natural explanation, Loeb reached a controversial conclusion. The only power source that matches the data is something artificial like a nuclear reactor. The energy signature matches what we'd expect from a controlled nuclear power source, rather than any natural process. This level of energy production, stable, continuous, and massive, is the strongest evidence suggesting 3I Atlas might be artificial rather than natural. Nothing in our current understanding of comets or asteroids can explain how a space rock could generate this much power on its own. Size discrepancy. One of the most puzzling aspects of 3I Atlas is figuring out exactly how big it is. And this is where things get really interesting. Originally, NASA scientists thought 3I Atlas must be enormous, about 20 kilometers across, roughly the size of Manhattan, based on how bright it appeared from Earth. That would make it one of the largest comets ever observed. But that created a huge problem. Objects that big from outside our solar system should only pass through once every 10,000 years or so. The odds of seeing one right now, just 8 years after discovering Oumuamua, our first interstellar visitor, would be astronomically unlikely, like winning the lottery twice in a row. This is where Loeb's team made a breakthrough. They realized that if the object is generating its own light instead of just reflecting sunlight, it could actually be much smaller than initially thought, maybe just 100 m across, about the size of a football field. This completely changes how we understand the object. If it's actually much smaller than initially thought, but still producing enormous energy, that makes its power output even. The size calculation is critical because it helps explain why this object might have been sent to our solar system. A smaller object would be much easier to accelerate to high speeds and control precisely, just like we humans would design a space probe to be relatively small and efficient rather than massive. If 3E Atlas is indeed smaller than originally thought, it would match the profile of what we might expect from an artificial probe rather than a natural object. Its size would be perfect for a reconnaissance mission. Large enough to house advanced equipment, but small enough to be maneuverable and efficient. This size discrepancy represents one of the strongest pieces of evidence, suggesting 3 Atlas might not be what it initially appeared to be. If it's a smaller object generating its own light rather than a massive comet reflecting sunlight, everything about how we understand it changes. Suspicious trajectory. Perhaps the most unsettling discovery about 3I Atlas is its path through our solar system. Most comets and asteroids follow random chaotic paths determined by gravity and initial velocity. But 3I Atlas seems to be following what Loeb calls a suspiciously perfect trajectory. Loeb's calculations show that its path allows it to closely pass 4 planets, Earth, Mars, Venus, and Jupiter. Not just one planet, which might happen by chance, but 4 major planets in our solar system. The odds of a random interstellar object happening to pass close to 4 planets are incredibly small, less than 0.005%. Loeb points out in 99.995% of cases, such an object would just zoom past without any meaningful planetary encounters. What makes this even stranger is that the trajectory seems perfectly timed. When 3I Atlas reaches its closest point to Earth on December 19, it will be positioned on the opposite side of the Sun, making it impossible for us to observe it clearly. This positioning seems almost deliberately designed to allow the object to observe Earth while preventing Earth from observing it, like someone wanting to study us while staying hidden. Some astronomers argue this is just coincidence. But Loeb believes the mathematical odds against such a perfect trajectory happening by chance are astronomical. It's as if the object is following a carefully plotted course through our solar system designed to study our planets while avoiding close observation from Earth. This isn't just unusual. It's statistically almost impossible without some form of guidance or intelligence behind it. While mainstream scientists continue searching for natural explanations, the numbers themselves paint a disturbing picture of what might really be happening. Strategic sunblocking. When 3I Atlas reaches its closest approach to Earth on December 19, 2025, it will be positioned on the opposite side of the Sun from us. This perfect alignment means Earth's most powerful telescopes won't be able to observe it during the most critical moment of its journey through our solar system. Scientists are puzzled by this timing. It's like someone wanting to take your picture, but deliberately standing behind a bright spotlight exactly when they press the shutter button. You're left completely blinded while they get a perfect view of you. What makes astronomers like Avi Loab suspicious is how perfectly this positioning aligns with the object's trajectory. If 3I Atlas were just randomly tumbling through space, the odds of it passing behind the Sun precisely during its closest approach to Earth would be incredibly small. This strategic positioning creates a one-way observation situation. If there were any cameras or sensing equipment on 3I Atlas, they would have a perfect view of Earth fully lit by the Sun. Meanwhile, Earth-based telescopes see nothing but blinding glare. Some scientists argue this is just coincidence. Objects passing through our solar system regularly get blocked by the Sun at some point in their journey. But what's unusual here is the precise timing. It's not just that the Sun will block our view at some random point, but specifically during the closest approach. This has forced space agencies to scramble to gather as much data as possible before and after the December sunblocking event.